Welcome to this explainer on Form 2 Mathematics, Chapter 1. Today, we're taking a deep dive into patterns and sequences. I want you to step into the role of a pattern detective with me. You know, math isn't just about memorizing boring formulas. It's about looking closely at the world, picking apart the structure, and unlocking the hidden rules that govern how numbers and objects interact. If you can spot the pattern, you can solve the puzzle. So grab your mental magnifying glass and let's get ready to decode some math. Here is our quick roadmap for today. We'll be covering 1. Spotting math patterns. 2. Pascal and Fibonacci numbers. 3. What is a sequence? 4. Finding the nth term. And we'll wrap up with 5 summary and revision tips. Let's jump right in.
Section 1. Spotting math patterns.
Okay, so what actually is a pattern? Well, it's simply a list of numbers, or even objects, that are arranged based on a specific rule or design. It's definitely not random. There's a clear logic driving it. And honestly, finding that underlying rule is the single most important step for literally everything else we're going to cover in this chapter. And hey, keep in mind, patterns don't just apply to numbers. They totally apply to shapes and visuals too. For example, you might look at a sequence of images and suddenly realize, oh, the rule is just adding 2 dots to the previous object. Or maybe you see a growing shape, and the rule is to just add 1 triangle each time. By identifying that visual rule, you can confidently predict exactly what the 100th or 1000th object in that design is going to look like. It's pretty cool. Let's look at how we can pull patterns out of a mixed set of numbers. Take a sequence like 7, 12, 17, 22, 27. If we just extract the odd numbers, so 7, 17, 27, 37, a beautifully clear rule emerges. We're just adding 10 to the previous number. Now, what if we pull out just the even numbers? 12, 22, 32, 42. See what happens there? It's the exact same rule. We are still adding 10. Sometimes, simply organizing your data is the secret key to making a hidden rule completely obvious. Moving on to Section 2, Pascal and Fibonacci numbers. First up is Pascal's triangle, which is basically a giant historical math puzzle. To build this thing, you start with a 1 at the very top. Then, every number below it is created by adding the 2 numbers directly above it together. But here is the crazy part. Look closely at the diagonals hiding inside the triangle. You'll find a sequence of 1, 2, 3, 4, 5. That's a super simple add 1 rule. Look at the next diagonal down, 1, 3, 6, 10, 15. The gap between those numbers is 2, then 3, then 4, then 5. It's literally a pattern inside a pattern, all generated from basic addition. Then we have the legendary Fibonacci numbers. This sequence starts with 0 and 1. The rule? You just add the previous 2 terms together to get the next one. So 0 plus 1 is 1. Then 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. And it goes on like that forever. Fun fact for you, Fibonacci originally used this exact sequence to calculate how fast rabbits could breed. Today, we see this elegant, simple rule constantly in nature, from the spirals of a pine cone to the petals of a sunflower. Section 3. What is a sequence? Mathematically speaking, a sequence is defined as a set of numbers or objects arranged according to a certain pattern. Now, I really want you to mentally underline that word, certain. It means the rule has to be reliable. It absolutely has to be consistent across the entire set. To really wrap our heads around this, let's compare a valid sequence against a super common mistake. If your numbers jump by 4, then by 4 again, then by 4 again, that is a sequence. The pattern is consistent. But if you have a set of numbers and the gap between them jumps randomly, like, say, adding 2, then subtracting 5, then adding 12, there is absolutely no consistent pattern. Therefore, it is not a sequence. If the rule breaks, the sequence breaks. Simple as that. Once we know we're looking at a valid sequence, like 1, 9, 17, 25, 33, we can actually describe its role in 3 different ways. The first is with simple numbers, just writing plus 8. The second is with words, stating, add 8 to the previous number. But the third way, that's the real boss level of this chapter, using algebraic expressions. We can write this sequence as 1 plus 8n. This algebraic rule is incredibly powerful because it captures the entire behavior of the sequence in one tiny little formula. Section 4, finding the nth term. First off, let's get familiar with this notation, T underscore n. Don't let it intimidate you. The capital T simply stands for the term itself, meaning the actual number in the list. The small subscript n just stands for the position of that term in the line. So, in the sequence,
4, 8, 12, 16. The first number, 4, is in position 1, so we call it T1. The fourth number, 16, is in position 4, so it's T4. See? It's just a handy labeling system to keep our math organized.
All right, let's put this into practice with a classic test question. If a sequence starts at the number 2 and the pattern is adding 8 to the previous number, what is the fifth term? Take a second and think about how you'd solve this.
Okay, here is the foolproof step-by-step logic you should be writing down on your exam paper. Step 1, always write down the pattern. In this case, it's add 8. Step 2, carefully list out the terms one by one. T1 is 2, T2 is 2 plus 8, which is 10, T3 is 18, T4 is 26, and finally T5 is 34. So boom, your fifth term is 34. Listing it out this way totally prevents simple arithmetic errors and proves your logic to the examiner.
Now, what if we flip it? Let's try a reverse problem. This time I'm giving you the sequence: 65, 60, 55, 50, and so on. Your challenge is to figure out the position n. Which term in this sequence is going to be exactly 40? We're going to use the exact same strategy. Step 1, determine the pattern. Going from 65 to 60 means we're clearly subtracting 5. Step 2, just list the terms down until we hit our target number. T1 is 65, T2 is 60, T3 is 55, T4 is 50. Continuing that pattern, T5 is 45, and T6 lands us perfectly at 40. Therefore, 40 is the sixth term. By meticulously tracking our T numbers right alongside our values, we literally can't go wrong.
And finally, Section 5, Summary and Revision Tips.
Okay, here are your golden revision rules to take away today. First, whenever you look at a new problem, identifying the rule is always your step 1. Second, check for consistency. If that rule changes midway, it's not a sequence. Third, make sure you're comfortable describing these patterns using numbers, words, or algebraic expressions. And finally, when dealing with those T sub n problems, write out step 1 to find the pattern and step 2 to list the terms. It keeps your work neat and guarantees accuracy.
As we wrap up, I really want to leave you with this thought. Math isn't just a list of random, frustrating numbers. It is a highly reliable system of rules just waiting to be discovered by you. You have the tools now to decode these sequences, to figure out the logic, and to predict what comes next. You are absolutely capable of being top-tier pattern detectives. So, step away from the screen for a bit, look around you, and ask yourself, what hidden sequences will you discover in the real world today? Because once you start looking for patterns, you realize they are everywhere. Good luck with your revision and keep investigating.